If you clicked on the video, you're probably wondering, how does my code affect the environment? If you didn't click on this video, you're probably sitting on your couch watching YouTube autoplay on your TV, so you might be really confused. But let's talk about the environment and how your code affects it. As a society, we've become more environmentally friendly and self-aware of our destructive acts. It's still easy to forget that our computers and cell phones consume energy. According to Spectrum IEEE, the average smartphone consumes only 4 kilowatt hours a year. Depending on where you live, it's anywhere between practically 0 and 9 pounds of CO2. With there approximately being 307 million smartphone users in the United States alone, that only equates to 14 million US tons. Which in the grand scheme of things, that isn't a lot, but that's not where the majority of calculations happen. With the rise of the internet and software as a service, most calculations happen in large server rooms. Google used 12.4 terawatts of energy in 2020, Facebook used 7 terawatts, and one of the worst offenders was YouTube using 243 terawatt hours in 1 year. The average user doesn't have any control over the power consumption of their apps or services. However, the future and current software engineers have the power to control our program's efficiency. What most programmers don't know or even think about is how inefficient their preferred programming languages are. As computer science evolved, we've been trading off efficiency with ease of use. Python, being one of the easiest languages to write for and get used to, is one of the most inefficient in power consumption. Python is a great start, but no real application, especially neural networks, should be written in them. Who decided TensorFlow should be a Python library? However, Mozilla has taken steps to a more energy-efficient future. With the creation of their programming language Rust, it being slightly more efficient than C++, which was the most efficient object-oriented language since the creation in the mid-80s. The only language that is faster than C++ is C, and then assembly language and machine code. I'm not saying to start programming in assembly nor machine code, because you may be able to write more efficient code, but most people will not. A lot of very smart people wrote the compilers to refactor your code, to utilize the tricks so you don't need to be an expert on assembly. However, that does not mean you shouldn't know the basics of assembly. When making a decision on syntax, knowing the compiler and how it's going to interpret what you wrote can make a decision a no-brainer. You may hear colleagues, professors, bosses, and even random people on YouTube you should definitely subscribe to talk about expensive functions. What does that even mean, expensive? We mean it takes a lot of clock cycles, or it has a non-linear big O notation. I'll get into big O notation in a different video, so stay tuned. But clock cycles, what are they? How are they relevant? Clock cycles refer to the number of times the CPU needs to be called to perform one function. Using the x86 architecture, to calculate a simple log function, it takes 85 clock cycles. Depending on your CPU and optimization, it may take 30 to 60 cycles to perform division. Multiplication takes 6 cycles, and an if statement takes 3. Switch statements also take 3. So what gives? What even is the question of the video? Which one's more efficient? Well, depending on how your compiler is written and how smart it was written, the efficiency drops off when loading variables to the register. There is no difference between the if statement and the switch statement if you only have one else. However, the efficiency drops when you have more else if statements, making it no longer the most efficient way. You may still be confused on what the difference is. Every time a computer does a comparison, it has to load the two values that is comparing to the register. It takes 1 cycle to load each value. Both switch statements and if statements take 3 cycles, not including the loading time of variables. When doing an if-else statement, the computer has to load each one of the values to the register every single time. On the other hand, if we have a switch statement, which limits you to only using one value and then you can change the other comparisons, the computer only must load the first value once and it overwrites the second value. This saves 1 clock cycle per every if. Roll credits. Wait, don't leave yet. We still have tests. Although the answer was given, please watch. Now for the test, I wrote a Rust program that writes Rust programs. This test is comparing 1,000 if statements to 1,000 match parameters. I ran each one of these tests 10,000 times. It took the ifs 1.28 seconds to complete, and it took the matches 1.2 seconds. I know, huge difference, right? 100% reasonable test case as well. But the code you write might be used millions of times by people, and a small performance boost may make the world of difference. If you got this far in the video, thank you so much for watching, and please consider subscribing. This is my first video essay on programming techniques. If you liked it, please hit the button. If you want more, leave a topic suggestion down in the comments. Follow my GitHub for any projects I'm working on. Again, thank you guys so much for watching. See you guys later. Bye.